Hi friends, today we are going to build something different. We are going to make two microcontrollers communicate to each other. Like here Arduino and ESP32 are communicating to each other. So whatever the Arduino is saying to ESP32, that is printing here, and whatever the ESP32 is saying to the Arduino, that is printing here. So ESP32 is saying yes, I have dual cores, then Arduino is responding that two brains show off, right? So in this way there is a conversation between Arduino and ESP32. So let us start building this project and understand what is happening here. Now you can see there are two programs here. This is for Arduino and this is for ESP32. And first of all, let us discuss about software serial library and hardware serial library. So hardware serial library basically lets you to make use of UART pins for the communication purposes, right? And it basically allows your UART module, which is already present inside your microcontroller chip, to handle all the work of sending and receiving data in the hardware and without making use of CPU. That is why this hardware serial is very reliable and faster even in case of higher baud rates. Now coming on to the software serial library. So basically this library lets you to create a fake serial port inside a program that you have written here so that your Arduino can communicate to more number of devices. And this library is used when you are lacking with number of serial ports. And you can use any two digital pins on the microcontroller like Arduino and use them as TX and RX. Like I'm using pin number 2 as RX and pin number 3 as TX, right? And you may ask that why we are using software serial library inside this Arduino code and not in ESP32 code, because the Arduino has only one UART communication port which is connected to pin number 0 and 1. And these Arduino's built-in TX and RX pin are used to communicate to the computer and print the data on the serial monitor. And if we connect any other device or peripheral with these TX and RX pins, then it will give you messy values. So that is why we should avoid connecting this RX and the TX pin of the Arduino to any other peripheral device. Now let us understand both the programs. So starting from the ESP32 code, in this line we are defining an instance of hardware serial library named chat serial, and it is taking an input of 1. Now here 1 represents that we are using UART number 1. So basically ESP32 has 3 inbuilt serial communication ports, UART0, UART1 and UART2. So UART0 is mapped to the pins TX0 and RX0 on the ESP32, and these are the default pins which are used to establish the communication between the laptop and the ESP32 and also for the debugging purposes. So we should avoid using this TX0 and RX0 to any of the hardware peripheral. The second serial port is UART1, which is mapped to pins 9 and 10. Okay, so 9 is mapped to RX and 10 is mapped to TX. But in this image you will not see the GPIO 9 and 10 because they are present inside this metallic case, right? And these pins are connected to the internal flash chip of the ESP32, and these pins are used to communicate to the internal flash memory chip of the ESP. And you can also remap these 9 and 10 pins to any other GPIO pins on this ESP32. The third serial port is UART2, which is connected to TX2 and RX2. So TX2 is connected to GPIO 17, this one, and RX2 is connected to GPIO 16, this one. And in this project we are going to use these pins TX2 and RX2 because they are not connected to any other internal hardware of this ESP32 board. So we should not use UART1 in any of the project because firstly it is inaccessible by the user, and secondly it is connected to the internal flash memory chip of the ESP32. So as I've told you that we can remap the GPIO 9 and 10 which is present inside this metallic case to the GPIO 16 and 17. Okay, so in this line we are basically telling the ESP not to use the default 9 and 10 pins, but we are forcing the ESP to use 16 and 17 pins, which corresponds to UART2. And this parameter is representing the communication is of serial type. 8 is for the length of the data, that means 8 bits, and represent that there is no parity bit, and 1 is representing that the stop bit is there. So I'm not getting into the details of this data format, otherwise the video would get too long. And 9600 is the baud rate here. Now instead of 1 I could directly use here number 2, which is for the UART2 port, but I wanted to tell you that what is going here in this line. So the mapping that we are doing here in line number 9 is called the GPIO matrix or pin remapping. So if you use number 2 here in this line number 5, then you don't need this line, you can comment this line, right? Now let us move on to the main loop section in this program. So if chat serial.available, this line means whether the data is coming from the Arduino or not. If data is coming, then this portion will be executed, otherwise not. And we are reading that message until this new line character arrives. okay, and storing that response into this message variable. And in this line number 17, we are basically eliminating all the extra spaces and extra characters from the sentence. And if the message length is greater than 0, that means if some characters are present in the message, then we are giving this response to the Arduino. So if this keyword is available or present in the response of the Arduino, then this sentence will be printed on the serial monitor of the Arduino code. Okay. And if this keyword is not available in the response of the Arduino, then this condition will be false and the message won't be printed. Right. Let me give you an example. Like here Arduino is saying, hey, you wake. Okay. So awake is present in this sentence. So this portion will be executed on the serial monitor. Suppose if I write here, hello, then this condition will be false because hello is not available in this sentence, right? So this portion won't be executed. And similarly, all the responses are very similar to this response number 1, okay? And the loop section of this Arduino code is also similar to the ESP code. Now we will see the connections between both the microcontrollers. And on the ESP32, you will find two types of UART communication pins. First of all, TX0 and RX0, and TX2 and RX2, right? And we will connect the digital pins of the Arduino with these pins, TX2 and RX2, and not with the ones which are labeled as 0, right? And the reason I have already discussed in the program. So let us connect the pins. So in the program, I used the pins number 2 and 3 of the Arduino. So connect the pin number 2 with TX2 and pin number 3 with the RX2. And we should also make a common ground between both the microcontrollers. So for that purpose, connect the ground of the ESP with the ground of the Arduino. Now actually this is not a recommended connection between both the microcontrollers because the digital pins on the Arduino output 5 volt and the maximum voltage that the ESP32 pin can handle is maximum 3.3 volt, right? So for that purpose we will require a set of resistors. Now all of these 6 resistors are creating the voltage divider circuit, and each of these resistors is of 1 kilo ohm each. And this blue wire is connected to pin number 3 and this is connected to pin number 2. And this black and gray wire are connected to the ground of the Arduino. Okay. And you will see the potential difference between this point and this point is 5 volt, and similarly here between this point and this point is 5 volt. Let me show you in the multimeter. Okay, you can see in the multimeter the potential difference is 5 volt, and across these two resistors the voltage is around 3.3 volt. Okay, and similarly here you will also see that potential difference between this and this is 5 volt, and this point and this point is 3.3 volt. Let me show you here also. You can see the potential difference is 5 volt, and across these two resistors the difference is 3.3 volt, right? So we will take out a jumper wire from this point and from this point, and we will connect those two jumper wires to the TX2 and RX2 pins of the ESP32. Now we will take out a jumper wire from this point, right, and from this point. And you remember we connected the pin number 2 of the Arduino to the TX2 pin of the ESP32. So pin number 2, that means orange wire, is connected here. So we will connect this red wire to the TX2 pin. And similarly this green wire will be connected to the RX2 pin of the ESP. Okay, and we need to also have a common ground. Here still we do not have a common ground between both the microcontrollers. For that, take out a jumper wire from ground of Arduino and connect it here, ground of the ESP. Now this is a complete secure connection between both the microcontrollers. So if you enjoyed this video, hit the subscribe button, and if you have any doubt regarding any of the function in this program or in this program, then comment it out in the comment section, and let us meet in another video.